Good evening, dear colleagues. My name is Nikita Remnev, and today I'm going to tell you some words about my research. The topic of my presentation is native language identification for Russian. I'm from Higher School of Economics. Nowadays, I'm a PhD student at Doctoral School of Computer Science. Some words about presentation plan. I've divided my topic into several points. First, we will talk about problem statement and what is it, native language identification, and why it is needed. Then we will briefly talk about shared tasks on an NLI topic conducted in 2013 and 2017. After that, we will discuss, I will tell you some words about Russian learner corpus, because it's very important for my research, which is totally that data driven. After that, I'll briefly discuss a model I used for experiments, and I will show you some results of experiments. I'll finish my presentation with some drawbacks of current approach, and I'll draw some further research directions. So let's start from the problem statement. The core idea of native language identification is that there is an assumption that authors of texts with one native language, as well as speaking, have similar characteristics. Authors often modify the Russian words linked to its spelling words in native language, and also authors also use some appropriate for their native language construction, but these constructions or some words which were brought from native language are not correct in Russian. So what is it, native language identification? Native language identification, or NLI in short, is a task of automatically classifying the native language of a writer based solely on his or her essay written in another language. The problem area has seen a spike in interest in recent years, as it can have an impact on educational applications tailored towards non-native speakers of language, as well as authorship profiling. Native language identification can be useful for a number of applications. For example, it can be used in educational settings to provide more targeted feedback to language learners about their errors. For example, also a writing tutor system which can detect the native language of the learner could be able to tailor the feedback about the error and contrast it with common properties of the learner's language. In addition, native language is often used as a feature that goes into authorship profiling, which is frequently used in forensic linguistics. When we talk about native language identification, there are two large competitions were conducted in 2013 and 2017, which are have several works. Some of them could be called as some state-of-art works. So let's briefly talk about analyze shared tasks. Analyze shared task, which was conducted in 2013. It was the first shared task for native language identification, and it was very important to this task for developing. While there has been a growing body of work in NLI, it has been difficult to compare methodologies because of the different sets of data used. In the NLI shared task, in 2013, authors provided a large corpus designed specifically for this task. In this task, a total of 29 teams from around the world completed across 3 different subtasks, and best accuracy between 5 runs for each system provided was 83.6%. For these tasks, the dataset was specifically developed. It was a TOEFL 11 corpus of non-native written English. This corpus consists of essays written during a high-stakes college entrance set. The corpus contains 1,100 essays per language, sampled as eventually as possible from 8 prompts, topics, along with score levels, low, medium, or high, for each essay. The 11 languages covered by this corpus are Arabic, Chinese, French, German, Hindi, Italian, Japanese, Korean, Spanish, Telugu, and Turkish. The TOEFL corpus was designed specifically to support the task of native language identification because all of the essays were collected through ADS, Operational Text Delivery System. The encoding and storage of all text is consistent. Some results of this shared task. The slide you can see the top machine learning methods used by teams in this task. While there are many machine learning algorithms to choose from, the overwhelming majority of teams used support vector machines. And this, of course, may not be surprising given that most prior work has also used SVMs. 4 teams also experimented with different ways of using ensemble methods. 3 teams used maximum entropy methods for their modeling. And finally, there were a few other teams that tried different methods, such as discriminant function analysis and nearest neighbors. Sorry. When we're talking about features used, spelling correction technologies for languages with rich morphology are still fully covered in academic literature. So when we talk about the top features used, of course, some of them could be better for Russian or worse for Russian. As for TOEFL 11 corpus, there are several features used by teams. Of course, the most common feature is word engrams, then comes pose engrams, character engrams, function engrams, and some authors use synthetic features and spelling features. But of course, the highest results and the most common approaches use just simple word engrams. In 2017, another shared task on NLI topic was conducted. This shared task uses the data from 2013 shared task with additional speaking responses, text written. There were 3 tracks, NLI on the essay only, NLI on the spoken response only, based on a transcription of the response and iVector acoustic features, and NLI using both responses. A total of 18 teams completed across the 3 different subtasks, and multiple classifier systems were the most effective in all tasks, with most based on traditional classifiers, for example, SVMs with lexical and synthetic features. Best teams shows nearby 88% of accuracy. When we're talking about NLI for Russian, of course, the data used for this research is very specific. So this research is only possible to Russian learning corpus, which is the corpus is a collection of texts produced by two categories of non-standard speakers of Russian. It's learners of Russian as foreign language and speakers of heritage Russian with different dominant languages. The corpus contains both oral and written production and enables search by morphological properties and a variety of deviations from standard Russian, ranging from mistakes in orthography and grammar to non-standard use of lexical and synthetic constructions. The majority of texts are coming from teachers of Russian as a second language and or heritage language in different countries. Russian learner corpus comprises both academic and non-academic texts, such as movie and picture descriptions, book summaries, expository essays, and others. There are 15 native languages in corpus. For developing this corpus, 12 countries partners and 20 universities partners were working on development of that. A Russian learning corpus was developed by Higher School of Economics laboratory, and now it's developed only thanks by Faculty of Linguistics and this research is head of this research is Rahil Nikita. Let's briefly discuss some statistics for this corpus. For the 1st of May, the following statistics for Russian learning corpus is actual. There are 8,500 texts with 138,420 sentences. In total, corpus contains approximately 638,000 words, and the corpus has also manually marked 73,000 of errors, which is done manually, and this is a very time-consuming task. Here are the slides, some statistics about text distribution by native language and by speaker types. As you can see, corpus is not well balanced. For example, for Estonian language, we have only 2 texts, while for, of course, English, which is the easier to obtain English text, English speakers text is more than 3,000. So for making experiments on analyze task for Russian, the simple but quite effective model was developed. It's very simple, and of course many of you are familiar with these things. This model just contains from word engrams, TF-EDF metric, and support vector machine. I use this model to applying this for Russian learner corpus text, and here are some results obtained. First, here are some results for different engrams, order for unbalanced corpus data. All the texts were used, and in this case, rare languages are not detected at all, and high precision accuracy is achieved with English language support, which has more than 3,000 of texts. Higher engram orders reduces precision, as for 1 and 2 engrams together, accuracy dramatically fall for if we use engrams with more than 2 types of engrams, for example, 1 gram, B gram, 3 grams together, the accuracy in this case dramatically fall because of the huge number of features I used. Precision was calculated by cross-validation in 5 cycles. So the best accuracy achieved for the first experiment with 1 gram and B gram, it was nearby 88%. Corpus, after seeing this picture, of course, it was necessary to balance the corpus, and corpus was balanced in the following way. Sweden author's text it has 178 texts for Sweden were taken, and languages with more than this number of texts were taken. If number of texts for native language was more than, of course, this was than 178, this number of texts were reduced. Also, some anomalies influence with prompts of text, for example, ecology, then for Japan, were reduced if possible, because it could affect the total accuracy, because there are some specific words in this text. For balanced results, accuracy was dramatically decreased. Best results were achieved for, again, for 1 and 2 n-grams order with accuracy of 80%. Another interesting task experiment was conducted on corpus. It's speaker types classification. There are 2 types of speakers. First is the learners, simple learners of language, so it's foreign language learners. And the second type of speakers is very interesting. It's heritage speakers. As a rule, these are some kind of people who learned a language in childhood, but due to various reasons, they use another language as the main one. So again, statistics for speaker types for Russian learner corpus. And this model was applied to speaker types classification. And here are some results. The mean accuracy was 88%. Of course, still 5-fold cross-validation were used. And for balanced case, the accuracy was nearby 87%, but it's interesting that learners and heritage speakers precision swap places in balanced case. One more interesting experiment, it's classification based on error types. As I already told, Russian learner corpus contains 73,000 of manually marked errors. It is well known that different speakers of different languages makes different kind of errors when learning a language. And this fact makes possible to use error type statistics in text for NLI classification. Here are classification based on error types and some top errors for language in Russian learner corpus. Statistics is proved the fact that different language have different kinds of errors. Of course, there are common error types for most of language, for example, ORSA and LEX errors. But still, the top error types for different languages differs. And here are some results for these experiments. Nearby 80% accuracy for balanced corpus and 72% accuracy for balanced corpus were achieved. So let's move to some drawbacks of these experiments. Of course, there are several drawbacks of this approach. The first one is lack of the data for training and testing. In balanced case, only 178 texts, no much than 1,000 texts in total. Another drawbacks is that corpus is not sufficiently balanced. Of course, if corpus was more balanced, and this research will be more correct. Also, there are some anomalies influence which may an effect. For example, it could be prompt because in Japan, there was topic about ecology, and some specific linguistics affect the accuracy if we in unbalanced case. Also, language level may also affect different types of speakers, and this could have some influence, of course, on the analytic classification too. Of course, the model used for experiments is quite simple, but for this number of texts, more difficult models for deep learning or neural networks could not be applied. For example, I used convolutional neural networks for this kind of task, and achieved results was quite poor. It's about 70% accuracy because, of course, the lack of the data used for learning. In conclusion, I'd like to say that for the task of recognizing selective language of the author of the text for the Russian language, the accuracy was equally to 80%, and for the task of determining the speaker type, the accuracy is equal to 87%. These results quite promising, and of course, if the data used will be more balanced and much more text were in corpus, the results could be quite better. I'll draw briefly further direction. First of all, there are 73,000 of text manually marked in corpus, in Russian learning corpus, so the recognition of the author's native language based on the mistakes is quite interesting task. Not in this kind of task, we will not base it on error types, we will base on particular errors. So if we have text of some author and we could detect some errors in this text, we could, by these errors, classify the author's native language. And if, of course, another important thing is to moving from simple model to more complex and more more applicable maybe for this task, more applicable for this task, for analyte tasks model. So of course, more complex model is required. So here are some references I used in my work. And thank you for your attention. Any suggestions, any questions are welcome. I'm sorry for my English and some talk problems, but still here we go. Thank you very much, and you could email me with your questions, suggestions. Thank you.